So we are going to be solving this problem. It has to do with two mirrors inclined at an angle. Okay, now let's check out the problem. Okay, look at the problem. Okay, I hope you can see this diagram. I hope you can see this diagram. I hope you can see it. I hope you can see. Okay, so let me read the question and then we'll tackle the problem together. Two mirrors of the same length are arranged as shown in the diagram above. A ray of light NO, this NO, okay, strikes the system at O and emerges along peak Q. This is peak Q. The emergent ray has been deviated through. So we are asked to find the angle of deviation. Simply put, we are looking for the angle of deviation. Now, for us to solve this problem, we are going to reproduce the diagram and then complete. But before we do that, let me quickly explain. Okay, let me quickly give you a general knowledge on reflection. So if we have a ray of light incident on a plane mirror, okay, let's say this is a ray of light incident on a plane mirror, okay, and it gets reflected, okay, of course it will get reflected. Now we have this. If we draw a normal, we have n, right? I just want to do this so that we tackle this problem, okay? So I want to have the general knowledge so that it doesn't look like as if I'm doing magic. Now, this angle between the incident ray and the mirror is the glancing angle. The angle between the reflected ray and the mirror is glancing angle. Okay. Now, the angle between the incident ray and the normal is the angle of incidence. Okay. Now, the angle between the reflected ray and the normal is the angle of reflection. Okay. Now, the angle of deviation, which is the problem or the problem we're looking for, okay, which is what we are looking for in this question. Okay, now the incident ray is reproduced downwards. The incident ray is reproduced. Okay, now this angle from the reflected ray down to this line reproduced is the angle of deviation. The angle, okay, between the reflected ray and the reproduced incident ray is the angle of deviation. I hope it's here. Can we tackle that problem now? Let's do this. So I am going to be redrawing this diagram, or better still, let me just, I don't know, if I don't want to wipe this information and at the same time, okay, let me complete this diagram. So the first thing first, we'll draw a normal. Okay, can you see? I've drawn a normal. So if I draw a normal, it means this is going to be 90 degrees. Okay, this is going to be 90 degrees. Are you here? So, and if this is 90 degrees, it means I can find this angle. How? 90 minus 40. 90 minus 40 will give me what? 50. And so we have 50 degrees here. So it means here is going to be what? 50 degrees. Is that okay? Now, by Snell's law, okay, the angle of incidence is equal to the angle of reflection. Okay, so by that law or by that fact, it means this is going to be what? 50 degrees. Okay, now we can, this is the incident ray, we can reproduce this backward. Let's reproduce this backward. So if we do this, this is the angle of deviation. This is the angle of deviation. So let's term this D1. You know why we are tagging it D1? Because the incident ray ON that emerges along PQ will deviate twice. Okay, it will deviate twice. This is the first deviation. Okay, now this one we are seeing here is incident ray for this. So we are going to reproduce this as our second incident ray. Okay, and let's complete this problem. this is the normal. Okay, so if this is normal, it means remember that principle, alternate angles are equal. So we can say that this angle alternate is alternate to this. This is equal to what? 50 degrees. Are you here? Okay, so if this is 50 degrees, are you following? If this is 50 degrees, here, from here to here is going to be 90. From this angle to this angle, like from here to here, is going to be 90. So we can find this small space. How? 90 minus 50 will give us what? 40. So we have here to be what? 40 degree. Okay, now this is the angle of what? For this particular point P, this is the incidence, this is the angle of incidence, and by the law, by that fact, angle of incidence is equal to what? Angle of reflection. It means that here is going to be what? 40 degrees. Okay, are you here? So this is what we are looking for now. This is the angle of deviation. This is D2. Okay, like I said before, I said that for incident ray ON that emerges along PQ. Okay, the deviation happened twice. So we have D1, D2. So the angle of deviation for this is going to be what? D is equal to D1 plus D2. Now let's go back to our sketch. What is D1? D1 is going to be this angle. Okay, so angle on a straight line, using angle on a straight line, we have 180 minus 50 minus 50. This is equal to 180 minus what? 100. So we have 80 as our D1. So we have 80 for D1 plus, what is D2? D2, using that same principle, angle on a straight line, right? So we have 180 minus 40. Look at it. 40, 40 minus 40 minus 40. Okay, this will give us what? This will give us what? 180 minus what? 80. This is equal to what? 100. So it means our D2 is 100. Our D1 is what? 80. So we have 100 here. So we have D1 is equal to 80. D2 is equal to what? 100. So 80 plus 100 will give us what? 180 degrees. So the emergent ray that has been deviated through 180. It is definitely not 220. It is not 200. It is not 210. It is definitely 180. And so our option is what? D. Okay. So you can see the angle of deviation, like I said before, is usually the angle between the reflected ray and the reproduced incident ray. Okay, now look at this. This is the reflected ray for this, and this is the reproduced incident ray. So this is the angle. That's why we have it as D1. So for this reflection, this is the incident, and that's why we reproduce it backward. Okay, so this is the reflected ray, the angle between the reflected ray and the reproduced incident ray. Okay, hope you enjoyed today's problem solving. If you have any question, feel free to drop the question in the comments section. I'm still Bukola Joseph, the physics enthusiast. Bye.